Geometric sequences. A sequence is geometric if the same number is multiplied each time to get from term to term. For example, 4, -8, 16, -32, 64, and so on forever is geometric because each term is multiplied by -2. And this is referred to as the common ratio, or R. An easy way to find the common ratio is to divide the second term divided by the first term. Our first example says the nth term of a sequence is given. Part A, find the first 5 terms of the sequence. Part B, what is the common ratio? So we're going to have to, first of all, from 1 to 5, plug in numbers for n. So the first term, n would be 1. 8 times 3/4 to the power of 1 minus 1. So that would be 3/4 to the 0. Anything to the 0 power equals 1. Times 8 is 8. And then a sub 2, we would replace all of the n's with 2. And we get 6. A sub 3, replace all of the n's with 3. And that comes out to be 9/2, and so on. And so a sub 4, plugging a 4 in for all the n's, turns out to be 27/8. And when we put a 5 in for all the n's, a sub 5 is 81/32. So those are the first 5 terms of the sequence. Now the common ratio, what you multiply to get from one term to the next, like I said earlier, you can find by taking the second term divided by the first term, 6 divided by 8, and let's reduce that fraction down, 3/4. So that's R, that's the common ratio. In general, the formula for a geometric sequence, like the one we just looked at, is this. The nth term of a geometric sequence is a sub n equals a sub 1 times r to the power of n minus 1. So we want to determine the common ratio, the 5th term, and the nth term of the geometric sequence. So the common ratio first, r, is equal to, and we'll just do the second term divided by the first term. -12 divided by 144, reduced down, that would be -1/12. To find the 5th term, we use the formula a sub 5 is equal to the first term, which is 144, times the ratio, -1/12, to the power of n minus 1. Well, if we're on the 5th term, n would be 5. And so all of that worked out comes out to be 1/144. Then the nth term means we fill in all the information we have except for the letter n. So a sub n would be 144 times -1/12 to the power of n minus 1. Sometimes we want to add up parts of the list, parts of the sequence, and so this says find the partial sum of the geometric sequence that satisfies the given conditions. They give us that a, that should have a little 1 there, a sub 1 is equal to 5, r equals 2, and n equals 6. So the formula for the sum of the first n terms, you can see right here, and we have everything we need to fill that in. We want the first 6 terms because n is 6. The sum of the first 6 terms would be the first term, which is 5, and then times the fraction 1 minus r, which is 2, to the power of n, which is 6, over 1 minus r, which is 2. And all that comes out to be 315. Find the sum, 2 plus 4 plus 8 plus, and then there's a bunch of numbers in between, plus 32,768. So when we look at this, we can see that our first term, a sub 1, is 2, and then our common ratio, r, would be 4 divided by 2, which is 2, but we don't know n, and we need n for our formula. So to find it, we're going to have to use the formula a sub n equals a sub 1 times r to the power of n minus 1 to find it. Get that guy out of the way. Now, setting it up, a sub n, we know the last term. 32,768 equals a sub 1, which is 2, times r, which is also 2, to the power of n minus 1. Now you cannot multiply those 2's because order of operations says you do exponents before you do multiplication. So I can divide by 2 both sides, and then I would have 16384 equals 2 to the power of n minus 1. Now, how do I get to that n? How do I get that n out of the sky? Well, go back in time to our logarithms knowledge. Logarithms make exponents come down front. So if I do a log on both sides, the n minus 1 comes out front, and we have log of 16384 equals n minus 1 log 2. Divide both sides by log 2. Log of 16384 divided by log 2. And then hopefully you can see that if we divided out the log 2, then we would need to add 1 to get the n by itself. All of that in the calculator, and you come out with 15. You should always come out with a whole number because you're counting. N stands for how many terms there are, which always has to be a whole number. Now we can use our formula to find the sum. We know we have 15 terms. So the sum of the first 15 terms would be our first term, which is 2, and then 1 minus 2 to the 15th power over 1 minus 2. And it comes out to be 65,534. A series is a sequence in which all the terms are added together. So when we were finding the sums of the arithmetic and geometric sequences in the previous examples, we were finding the values of a finite series. Finite means the series has a specific number of terms and then it ends. You can count how many terms there are. There are only 5, or there are 15, or there are 100 million, but you can count them. But we can also find the sum of some infinite geometric series. These are series that continue forever and ever with no end. So to imagine how this works, think of the geometric series 1 plus a half plus a fourth plus an eighth plus a 16th, and so on and so on and so on. And in this series, r equals 1/2. You keep multiplying by 1/2, and the fractions will continually get smaller and smaller. So if you continue writing this series out from here to the moon and beyond, eventually the fractions get so small that adding them no longer has any effect. So we can reach an actual sum. In this case, the sum of this series is 2. Now that's not the most mathematically sound explanation, but it helps to understand how this is even possible. Now imagine the geometric series 1 plus 2 plus 4 plus 8 plus 16. In this case, r equals 2. And clearly this series will just go larger and larger and larger, and it's never going to settle down on a sum. So when a geometric series settles in on a sum, it's said to converge. That would be the first example I showed you. When it does not, it diverges, and that's the second example I showed you. And we can tell from the common ratio if the series converges or diverges. So if the absolute value of r is less than 1, the series converges, and the sum is s equals a sub 1 over 1 minus r. If the absolute value of r is greater than 1, then the series diverges. We want to find the sum, 10 minus 2 plus 0.4 minus, and so on forever. So we have to find r by dividing the second term by the first term. Negative 2 divided by 10 would be negative 0.2. Now we have to check for convergence. So I look at the absolute value of r. Absolute value of negative 0.2 would just be 0.2. That is less than 1. So that means it converges, and we can use the formula. The sum is the first term divided by 1 minus the common ratio. So it's 1 minus a minus 0.2 would be 1 plus 0.2, and it's 8.333. Now in the second example, 2/3 plus 8/9 plus 32/27 plus forever. The common ratio is 8/9 divided by 2/3. Flip and multiply 8/9 times 3/2, and you come out with 4/3. The absolute value of 4/3 is greater than 1, so this series diverges. It has no sum.